Okay, so we'll discuss about uplink transport channel processing and the steps involved in uplink transport channel processing are same as that of whatever the steps involved in downlink transport channel processing. That is, we broadly classify this transport channel processing operation into two things. One is channel coding processing and another one is modulation processing, right? So here also in the uplink transport channel processing is also same. That channel coding processing involves what the input to that is a transport block from the MAC layer, right? Then it undergoes CRC addition, then code segmentation, channel coding, rate matching, then code concatenation, right? So all these comes under the channel coding processing. Okay. So, this waiting room business why person number third. Fine. Okay. Screen. Share. I said it has channel coding processing and as well as modulation processing, right? So the transport block from the MAC layer goes to the CRC addition, means we are adding CRC bits for the purpose of error detection, right? Then it undergoes code block segmentation and then channel coding. Okay. So here channel coding is the same as that of what we have used in downlink transport channel processing. So like that is 1/3 turbo coding only is used as a channel coding technique, and that too that depends on type of channel used. And for control information, here basically we use two types of channels. One is a physical uplink control channel. Another one is a physical uplink shared channel. Okay. So depending upon what type of channel and what type of information, the channel coding technique is selected. Then the rate matching. After that, the code block concatenation. See, all these steps already I have discussed. Right? All these 5 blocks I have discussed here in the downlink transport channel processing. The same operations concept is same. So hence, I will not go so in depth about again saying what is done in each thing. So the main difference here is since in the uplink it does not support spatial multiplexing. Because of that, only one transport block per subframe will come. Okay, so that is the difference. And then the code word will be applied to the scrambling, then undergoes modulation mapping, Then DFT based pre-coding. This also we have discussed. After this, that is all about bit to symbol mapping. Then resource mapping. So the last block is different compared to the downlink transport channel processing. Okay. Only the difference in this here is the last block, that is SCFDMA signal generation. Okay. In case of downlink transport channel processing, it was OFDMA signal generation, right? As I used to say, for downlink, OFDMA is a multiple access technique used. See, for uplink, SCFDMA is used. So only that is the difference. And as I said here, transport block, only one transport block taken from the MAC layer for every subframe. That is another difference. And the rest all same. Okay. Just to say that, as I said, spatial multiplexing is not supported in the uplink. So because of that, the data streams from the MAC layer are presented to the encoding unit only one transport block every subframe. This is one thing. Then rest of the things are same. Right? Then that transport block undergoes the channel coding processing. That is, CRC bits will be added, then segmentation is done, then channel coding is done, then rate matching, then concatenation will be done. Then I get a code word. So that code word will be applied to the scrambler, then modulation mapper, then DFT pre-coding, then resource mapping. Then output of the resource mapping is given to the SCFDMA signal generation, right? So that SCFDMA signal will be mapped onto the resource block. See, that is what is written here. The modulated symbols are processed to generate the SCFDMA signals and mapped onto the assigned resource block. Okay. So, as I said, in this channel coding processing, for control information, the channel coding scheme depends on type of control information and also on type of physical channel that carries the control information. Okay, it is very simple here in the case of uplink because in the downlink so many control channels are there, but here it is only two channels in the uplink. Okay, one I said the physical uplink shared channel. See, the control information in the uplink can be mapped either to the physical uplink shared channel, that is PUSCH, or to the physical uplink control channel, that is PUCCH. And here this table gives you what type of channel coding scheme and what coding rate is used for this uplink transport channel. And similarly, the another table will give you the information about the channel coding scheme and the coding rate for uplink control information. So as I said, for the transport channel, okay, the channel is what uplink shared channel, and type of coding used is turbo coding with a coding rate of 1/3. It is the same as that of a downlink transport channel only. And for control information, okay, for control information in the uplink, the here it is, we say it is UCI, that is uplink control information. There in the downlink we used to say it is DCI, right? Similar to that, here we say it is UCI, that is control uplink control information. Okay, here we use two types of coding schemes. One is the block coding, and its coding rate is variable. Okay, another coding scheme used is tail biting convolutional coding, and its coding rate is fixed, which is 1/3. So this is what the main difference. Okay, compared to the downlink transport channel processing. Right, as I said, all the steps are same as that of a downlink transport channel, except the first one, that is the transport block. Means only one transport block will be taken from the MAC layer, okay, for every subframe, and the last block, that is SCFDMA signal, is generated and which is mapped onto the resource block. That is the only difference between uplink transport channel processing and the downlink transport channel processing. And another thing, as I said, in the channel coding processing, So depending upon the type of control information and the type of channel mapped to carry that control information, we use different types of coding schemes, right? So as I said, here there are two types of channels are mapped to the control information. Okay, one is the physical uplink shared channel, and another one is physical uplink control channel, that is PUCCH. As I said, for uplink transport channel, right, that is uplink shared channel, right? The coding scheme used was turbo coding with a coding rate of 1/3. For control information, that is UCI, we say uplink control information, two types of coding schemes are used. So one is the block coding, and its coding rate is variable. Another one is tail biting convolutional coding, and its coding rate is 1/3. So this is all about channel coding processing. As I said, output of the channel coding processing is a code word. That code word will be applied to the scrambler, right? Then modulation mapper, DFT pre-coding, I said. Then SCFDMA, and that is after a resource mapping, SCFDM signal is generated. So that all those process or steps comes under the modulation processing. So I will be taking about this, how the CFDMA signals are generated. That is after bit to symbol mapping, right? So that is the modulated symbols are applied as input to the DFT based pre-coding. Okay, that is a discrete Fourier transform based pre-coding. So output of this will be applied to the IFFT. So here the data is in the time domain. We convert that into frequency domain, right? So if I take again IFFT, inverse fast Fourier transform, again that I will convert it back to time domain, right? So that is applied to the parallel to serial converter along with the cyclic prefix. So to get the SCFDMA signals. I think already these things are discussed long back, right? How I get SCFDMA signal in detail about that. I think you can go back and see those slides also, so you'll understand still better, right? So next, what are the other things done in this uplink transport channel processing? We'll see. Okay. So if you have any doubts in this, you can ask me. So far, whatever I have discussed, as I said, almost all the steps are similar compared to when it is compared with the downlink transport channel processing, right? So if you have undergone that module, what I said, module 3 properly, then almost 70% of your job is done for module 4. Not even 70%, I think almost 80%, because almost all the channel coding processing blocks are same. Only in the modulation processing, last block is different, that is SCFDMA generation, right? Even that also we have discussed many times, how we generate SCFDMA signal. So if you have any particular question on this topic, you can ask me. So people are there. People are live or people are, I don't know. Nobody is speaking. Whether they are listening or they're doing something else. Hello? Hello?
Yes, sir.
Sir.
Yes, sir.
Yes,
Sir.
yes, sir.
Yes, sir.
Sir.
Hello?
Yes, sir.
Yes, sir.
Nobody is in
Yes,
call, I
sir.
think, I feel. Yes, Nishchit Roti. Nishchit Roti. Hello. Hello.
Hello. Sir, can you hear us, sir? Hello.
Hello.